I wanted to try a new I2S interfaced audio playback module, and IC Station sent me at no cost to review this PCM5102 DAC decoder board. So I'm going to just take a brief look at some of the specs and just try to get it up and running. The PCM5102 supports 32-bit audio, up to 384K sampling rate, and this module is set up to run between 5 and 10 volts, but it's got onboard 3.3 volt regulators. This module has everything all in one. You hook up the 3 I2S data pins, bit clock, audio data, and left-right clock, and then power supply and ground. The chip will do the rest, and we have stereo RCA jacks with line-out level audio. The only real configuration we would need to do is set this format jumper if we want between I2S formatted data or left justified, but I just leave it as is and it works with I2S. There's 2 separate ground pins where one can be used for the data and one can be used specifically for the power supply, but I'm just going to use one ground pin because my data and power are all coming from the same source anyway, and I don't want to create ground loops. So let's look at what I2S is all about. I2S, or Inter-IC Sound, is a serial interface for connecting digital audio devices together to send audio in PCM format, which is basically what's used in computers, CDs, etc. We only really need 3 digital lines. There could be a master clock as well, but all we need is the actual data for the audio, a bit clock for clocking that data in, and a word select, which can also be called left-right clock or frame sync, and that tells the system receiving the data whether it belongs to the left or right audio channel. Raspberry Pi supports I2S audio. They have a bit clock, left-right clock, and data pin. ESP32 also has an I2S interface, but I'm going to be using it with Teensy 3.6, where the bit clock data and left-right clock pins are here, and I'm taking 5 volts and ground coming in over USB to Teensy as the power source for this board. Then as a test, I'm going to take the line-out audio on one channel and put it on an oscilloscope, and the other channel is going to go to my little orange amplifier I always use for little audio projects. Just quickly looking at the datasheet for the PCM5102, you can look at it for more in-depth specs, but it's really an all-in-one IC solution where all we really do is provide power and some decoupling capacitors and maybe some audio filtering RC components, and that's it. So we have our I2S data, 3 different power pins to power a charge pump circuit, analog and digital power sources on the chip. So this is the basic component count that we would need: power supply rails and decoupling capacitors, digital audio input, and in line with each channel of audio out, we just have an RC low-pass filter. And that looks like essentially what we have here. Here's our audio out with a series resistor, capacitor to ground for a low-pass filter, what looks like a bunch of power supply decoupling, 3 separate 3.3 volt power rails to help keep any noise out of the analog path, and it looks like there's 3 series resistors in line with the I2S data, just in case maybe there's impedance matching issues and signal reflections. We can maybe tune those out. And it looks like here the traces are tweaked to maybe maintain the same length, so high-speed data and clock signals arrive at the same time. So it seems like a robust layout. Let's check it out and see how it works. Since I will be using this with Teensy, I start out with the Teensy GUI for the audio library, and we are going to want our Teensy audio output to go to an I2S board. It doesn't really matter which I2S chip we use. This is just digital data coming out on the I2S pins, and we have left and right inputs. So the first thing I want to do, as an input audio source, I want to try using USB. And this is similar to if we use an Arduino Pro Micro and we want to configure it as a USB keyboard, mouse, joystick type thing. We can do this in Teensy and have it show up in a computer as a digital audio interface. And this board only does sound output, not input. So when we plug this into a computer over USB, we'll suddenly have a Teensy audio device to generate sound out. And I can use it essentially as a sound card. Now, one of the things we can do with this, we can check over USB into the computer. We can ask what volume setting is the computer currently at. And that way, when we set the volume in the computer, it will also set it on this Teensy circuit. So on the left and right audio, I'm going to insert an amplifier. So that way I can ask the computer, what audio level do you want? And then I can set the gain on these amplifiers for each channel. And it's almost as simple as that to build a little Teensy sound card. As usual, if we now export, we get this header generated that we can copy in as a head start for a sketch. So it creates these objects to communicate over USB, give us control of a couple of amplifiers, and send audio out to the I2S bus. And of course, any audio connections we draw between objects are connected with patch cords. So this right here goes from the first USB channel over to amplifier 1's input, and so on. And once I write up a sketch using that header, this is really it. We allocate some memory to use for audio in the sketch. That's just a standard Teensy formality. And then in the loop, periodically, so I'm delaying 1/10 of a second, we poll the computer to ask what volume setting do they want over USB audio. And I set both amplifiers to that audio level. And that's it. We're just doing a pass-through, audio coming from USB source out to I2S with volume control. So we'll demo this in a second, but I also want to do something else. So we start again. Our output will be the I2S board. And this time I want to play back some audio samples from memory. And these are going to be drum samples, a hi-hat cymbal, snare drum, and bass drum, which I've done a project on before. I will link that for more info on how I do that. And I want to generate a test sine wave, just so I can look on the scope and see, does it look nice and clean? And I want to be able to play any combination of these back at the same time, so I need a mixer, and by default, the mixer is 4 channels. So I'll just give each of these audio sources their own channel. And of course it's mono, so I just copy the same audio to both left and right. And now in the sketch, I assign whatever samples I want to play back. I control the frequency and starting and stopping of a sine wave and these samples, set the gains if I want for different volume levels, and it's as simple as that. The header we get, when we click export, we bring that over into a sketch. And similar to my previous project playing back audio samples, I have copied those samples in. And when I look at the sketch, we've covered all of this before, so I'll just skip through. Patch cords are connecting all the sound sources to the mixer channels, and the mixer output goes to the I2S bus. In the setup, we assign memory for the system to use again. I set a default sine wave with no volume and 1 kHz frequency, and I preset the gain on each mixer channel. Then in the main loop, I just change the sine wave volume to essentially turn it on or off, and I change the frequency for a few test sounds. So I'm just generating some test signals for the scope. Then I turn the volume down for the sine wave, and I start playing back the drum samples in various patterns with delays, trying to simulate some sort of a little rhythm just to hear how it sounds, and that's it. The loop starts over with the test sine waves again, and so on. Here's how the USB sound output device sketch works. Let's queue up a YouTube video just as a test.
Hey guys, you're listening to the Simple Electronics podcast. I'm your host, Simple Electronics, for episode number 2.
And here's how the audio sample and sine wave playback work. This board was very easy to use. Just hook up a couple of wires really and plug in something to take the line level audio and it's good. Thanks to IC Station for sending me this at no cost to review. Thanks for watching. I'll see you on the next video.